Hi Aparna, how are you doing?
I'm good, sir. How are you?
I'm doing good too.
Yeah.
After a long time I have come to your class, batch 1.
Yes, sir.
So you must be angry with me. Why
No.
this person again?
No, not really.
Not really. Okay. Tell me Aparna, which project you have done? Yours is
Factors influencing customer satisfaction.
factors influencing. Is it here?
Last
Factors
one.
influencing.
Yeah.
Last one. Yeah. So you have done masters in economics, if I remember.
Yes, sir.
Yeah, I still remember that. So Aparna and Sukanna. Aparna, Sukanna.
Yeah. Sukanya.
Yeah.
Sukanya.
Sukanna. Yeah. Factor influencing customer satisfaction is a leading MNC bank. Okay. Let's go through. Yeah.
Yeah. We actually got this data from a consultant who did the analysis for this MNC bank. So, and primarily the data was actually collected by way of questionnaire, which they send through email to the customers of that particular bank.
You don't have to hold that. If you hold it, actually it is inconvenient to you.
No, yeah, okay, alright. So about around 210 responses was what we got. I mean, what the actual consultant got. And with that particular data set, we did our analysis. And the objective of our study was to determine the level of customer satisfaction and the factors that actually influence the customer satisfaction. So this was the basic thing that we wanted to find. And in specific, we also wanted to find which were the variables or factors that have more effect on determining the customer satisfaction.
So what did you do?
And yeah,
what are the
so
factors?
that was the objective. And yeah, the factors that we took in.
Yeah, no, but sorry. did you in the survey questionnaire, who prepared the survey questionnaire?
The questionnaire was prepared by the consultant who did the primary analysis for the bank. So we got the same data set for our project. Okay,
you got the data set for your project. So did you have to do some? Did you have to sign some non-disclosure agreement for the data you're using for this project? You had to. When they gave you the data. Did you have to sign some non-disclosure agreement that you cannot reveal this data external to your They have given you the data.
Yeah.
They have given you the data, and they permitted you to use for this project and discuss with others also.
Yes.
Okay.
Yes.
Okay, so you haven't you haven't created that questionnaire, but the factors were given to you.
No, I've also attached a questionnaire with this about document. It follows below this. It is there. The factors that we took in were, the variables we had were about 19 variables, of which 13 were the independent variables that we took into the study, so which you can see there. And our independent variable is obviously the customer satisfaction, which we took in. And 5 other variables are the demographic factors which we took, which is years of banking, gender, customer value, and mode of employment, all of those. So
did you do any segmentation or clustering based on any of this?
No, not really, but we actually tried plotting graphs to see how far customer satisfaction, is split based on gender and the customer value or the years of banking. So years of banking, we actually split it into three groups, where you have a group which has banking years were less than 1 year, 1 to 5 years, and more than 5 years. So based on that, we tried seeing how the level of customer satisfaction was. And also based on the gender, we also checked how the customer satisfaction was, which showed that female had more level of customer satisfaction than male as per the data that we had. Likewise, mode of employment also we had, that is, sorry, one second. Yeah, it was either corporate or a retail or private type of employment that we had, that is the accounts that the customers have. So based on that, what we got to know was corporates had lesser customer satisfaction than the private customers.
So you visually found the data to be normal,
yes,
but you didn't do
yes.
any other test, normality test.
Well, we going further, we have the PP plots there below.
Okay, you have, okay. I was looking for
yeah,
this.
the PP plots are there below, and we've also done a KS test.
Okay.
So the PP plots show the normal distribution because the points plotted are more towards on the line, so it shows the normality. And also going down to the KS test, yeah, so the KS test, again the p-value greater than 5% shows that there is the data, I mean the particular variable or factor is a normal factor. So if you see the parameter x2, the variable x2, x7 and x11 are the variables, those had a lesser significance level, which is not normally distributed. The other variables are normally distributed because the p-value is greater than 5%. Am I right? No?
First, let me hear you. Okay, then?
Yeah.
Yes, yes.
Okay, 1 second, please. Hello?
Yeah, go ahead, actually. I'm listening to you. I'll parallel, I'm going through the stuff.
Alright, then again, to find out which of these factors were actually had a higher significance level, we also check the mean of those variables. So since the data that we collected had a rating from 1 to 10 on a scale, 1 being poor and 10 being excellent, the way they actually collected data, gathered the information on the website was a drag and drop option there. So the data that we got didn't have just 1 to 10 values, but it had more absolute value or continuous values. So taking the midpoint of from 1 to 10, we got 5.5. So am I audible?
Yeah. Actually, I'm listening to you as well as I'm going through a document. That's right.
Okay. So we had the midpoint 5.5. So when you check the table there, the mean value greater than 5.5 indicates that the performance is above average, and lesser than 5.5 we considered that the performance is below average. So considering that the variables that are above 5.5 are communication of new products, and then the products that they offer, the pricing, and the helpfulness of all the employees to the customers. So these are the variables that have a better performance in determining the customer satisfaction. So this is one basic thing which we tried to find out which are the variables which would be significant. Further, we went ahead doing the regression analysis. So we used SPSS to get our output, to analyze our data. And yeah, so in order to choose our significant variables, we got our regression table and our ANOVA table. So as per the ANOVA table, the significance level, if it's the p-value, if it's less than 0.00, that is significance. Those were the variables that we took as our significant dependent variables. So considering that, we got 3 variables, that is employees, politeness of the employees, the communication, that is the level of communication to the customers, and how far are the employees trustworthy. So these were the three significant variables which actually had an impact on the customer satisfaction. So that's there in the next page, going ahead in the interpretation.
Yeah.
Yeah, so this table shows the three variables that have an impact on the customer satisfaction, a significant impact. So with that we built our model there, a regression equation. And going ahead, yeah, so one more thing was...
So what is your alpha you have considered?
Sorry, sir?
Alpha is 5% or...
Sorry, hello?
Your alpha significance level is 5%, no?
Yes, sir.
So now suppose in case of trust of employee, it is 0.3.
Yes, sir.
So 0.3 is what? 5% or 30%?
Okay, one second.
Think on it. Okay.
Alright, yeah, okay. Hello?
Yeah, wait, I'm just saying, yeah.
Yeah.
This is just a question, I'm just saying some questions. Suppose in this area, your significance is 5.54% and so and so.
Okay, sir, I really don't know about that.
As
far as we knew, we tried doing an analysis.
I'm just trying to confuse you.
Okay. Sir, I'm already confused a lot.
Look at it. Actually, look into it from a more of as a technical expert.
Okay.
So this is the outcome, or it's the outcome of a test, or it is just you have made this table in a Word and you have typed the data?
We've not typed it out. We've copied from what we've done, our output from
Okay,
SPSS.
you copied it from the SPSS?
Yes.
Okay. So in that case, you look at the SPSS output and think on it and explain us later, okay?
Okay.
Wherever you have considered the significance level and all, just explain.
Yeah.
I'm not telling you are right or wrong, I just thought of actually throwing a stone somewhere.
Okay. Alright. Can I get back with this? I mean, probably the next time I get the chance, because I would like to go through. Yeah.
No issues. My objective is to make you people learn. My objective is not to actually find faults. That's not conducted. You might have, I visited Chennai, you might have seen my objective is to patiently listen to you, understand that where all you can go wrong, and you see, it is not like that everybody will become an Einstein out of this course. No, that is not the expectation. We want actually wherever you are before joining the course, this course should actually add some value to you to a next level with respect to your earlier level. Isn't it?
Yes.
In this batch, actually, variety of people are there with a varied actually experience level, knowledge level, and so and so. So we don't expect everybody to perform equally. No, depending on your earlier status, where you are, that is more important, isn't it? You cannot be compared with a statistics graduate or postgraduate having 10 years of experience. You cannot be compared with a person who has an MBA and 10 years of experience. We don't want to do that. We don't want to do that business. But with your kind of background and all, whatever you have learned, let me see that what you have done. Okay?
Yes.
Okay. Anything else you would like to say?
So,
will I have to give presentation another day?
Yeah, well, actually my partner is also not there. If we can give a more clear presentation of
Okay, sure.
various other concepts that are below, then it will be
Okay,
fine.
so Sukarna, your partner is Sukarna.
Yeah, but she's not here today.
Okay, no issues. So we'll see another day, okay?
Okay, alright.
I'll fix another day for you.
Sure.
Okay, thank you, Aparna. With your kind of background and with your kind of, you are just fresh, you did a very good job. Okay?
Okay. Okay, thank you.
Abhishek, can I take you now? Samrat will take you, but Abhishek is pending.
Hello.
Yeah, Abhishek, yeah. Yeah, go ahead, yeah. Abhishek, we'll make
Yes,
it
sir.
very fast, okay?
Okay, sir. I'll try to be as quick as possible.
Yeah.
Can you open my slides, please? Yeah. Okay, so the title, as it says, high performance, which means doing parallel computing to do things fast for big data. The data is in the order of terabytes of genomic data, and we want to, it's largely in the healthcare sector. So the importance of scientific analytics in healthcare business, that is what we need to understand. So if you can go to the next slide. So we see the kind of money which is being poured in terms of grant and other kinds of disbursement by NIH, National Institute of Health in the US, for different ailments, diseases, such as for the human genome, it's $1,904 million, and for aging there is so much of money that is being poured in. So these kind of tell a kind of a proxy as to how important different diseases are, different aspects of research are. So that's why it is important. So this is where the business component fits in behind the scientific studies that I'm going to present. If we go to the next slide. So can we go to the next slide, please?
Yeah.
So essentially what we have is sets of chromosome inherited from mother and father, and we compare it to a reference genome, or the set of the chromosome is called a genome, and wherever the differences are, when we try to match up, those differences have been studied across different medical researchers to be associated in certain way to some kind of disease or attributes. So in this slide, for example, the autoimmune diseases, genetic diseases, and in the next slide it's cardiovascular diseases been mentioned. Then neurological diseases, neuropsychological diseases been mentioned. If you go to the next slide, sir, please.
Yeah, it takes time to try. Before you told I tried, but
Okay.
it takes more time
Okay.
than it.
Sure. Okay. So, for example, so it's the digestive disorders, and then there's female-specific disorders. All these, they're having like several decades or maybe even centuries of work that has gone in to understand what are these genetic blueprint that in some way are related to the diseases. For example, in this slide, the current slide, there are the variations shown in the cardio problems. So some of the variations such as AA, AG, GG, these variations have been given a name, and they have been associated with different kinds of cardio diseases. So my work essentially is to do a data mining on an individual, because the data is going to be huge. It's order of terabytes, and I need to build a model and then run it over cloud, private cloud or Amazon cloud, publicly available cloud, and use Hadoop or message passing interface or threads, and run this model to do the things in a very robust way. So the model in this current slide is that you have the upper line is, for example, the reference sequence, and the lower line is the test sequence. So the alignments are made such that wherever there is a match, we give a score, and the letters can be adjusted in such a way that there can be gaps also incorporated, and for every gap there is a penalty being proposed in, and there's also a penalty for gap opening, and gap extension there is a different penalty. So this is the model that I have made, and this model has a score that is associated with any two sequences. If they are aligned, based on the score you give for matches, and for mismatches there will be a penalty. For gaps there will be a lesser penalty. For gap opening there will be a higher penalty. So there will be a total score that comes up.
Yeah. Now, how do you decide that penalty amount? How do you decide the penalty amount?
Yeah, so that is a very good question, and it's quite debatable. I mean, it's a matter of how specificity versus sensitivity. So if you want the alignment to be more specific, you give higher penalty in general. There are some standards. I mean, people in bioinformatics domain use some standard, but you can vary these penalty amount depending upon how specific you want the matches to happen. But this is not the only step where you can put in specificity and sensitivity. There will be another stage later on, which is what we learned in this course using the p-value technique. So if we can go to the next slide. This is the model, and I'm going to use this model for extracting all the variations. For example, so in the next slide we see it has been studied by some researchers that this alignment, wherever there is a match, it's called a high scoring pairs, HSPs, because one sequence can match to another genome at different locations, and wherever there is a higher score above the certain cutoff, we call it a high scoring pair. And this follows a Poisson distribution. And so essentially so it's not just the score which is important, it is also the p-value and later on the expectation or the e-value, which is very important in deciding whether we pick up a match to be or not.
Would you please let all other participants know why it is a Poisson distribution?
It's in the research article which has been cited, and I didn't actually go and look at the details of the research article, but
it's interesting why it should be a Poisson distribution. Okay.
Because I think because any match happening is independent of any of the previous matches that is happening. So I mean, I can't be better than this if I read those articles. But in general, any matches are independent of the previous matches. So we can say that.
Right. I don't want to.
Yeah, of course, I'll read those. I've mentioned the references in the end of the presentation, but I'll definitely read those articles and come next time when I give a final presentation.
Yeah. Okay.
So this is what we know, and I put a cutoff of p-value 0.01, so that I ensure that the matches are not purely due to chance. Okay. So presentation. Yeah. So the matches are not purely due to chance, and this is the condition. And so this is on the left hand side. There's a plot of different percentages. So we can see a clearly diagonal line which is there. So the percentages are 70 to 95, 95 to 99, 99 to 99.9, and 99.9 to 100. So these are the different categories. I have not labeled it, but this is the whole general concept by which the whole plot will be there. And if you can go to the previous slide, I have mentioned that out of all these matches, I will pick up those which are maximal unique matches. So the unique matches are those matches which are not part of which is not a subset of a bigger match, and so from those unique matches I'll have to pick up the largest ones, and when I apply that on this one, then I get the bigger chunks, which is more or less the diagonal lines, that are being shown. So if so the right figure is pretty much self-explanatory. It's any given point we will have different other chromosomes where we can find the matches of this of exact match and the percentages that it differs by. So in this slide, so any genome reference or test genome will have variations which are known in the literature to vary as at a certain point, which is largely the subject of the talk that I'm giving, which is single nucleotide polymorphism, which is mentioned as SNPs. And there are other variations as well, insertions, deletions, inversions, copy number variations, which I'm not focusing on this talk. So my focus is on the left-hand side, which is single nucleotide polymorphism, which means that any two sequences are completely matching at certain location other than one single letter, and how those letters contribute to diseases and different findings. So if you can go to the next slide. So so here is the plot of Mr. Joshi, which is a totally anonymous name that I've given, and the next slide is of Mrs. Joshi. Then the next slide is of one of her daughters, Miss Kavita. All names are anonymous. And the next slide is of her second daughter, Razia. So we get a pictorial view of the family of 4 people as to how it varies. And here is a sample of after extracting those data, I put it in the data frames using the read-date.table, which we learned in this course. And this is how the data looks like. The first column tells, if you go to the previous slide, the first column tells about the location on the reference genome. The second column tells about the letter at the reference genome. The third column tells the letter which mismatched at the test genome. The first one is for Mr. Joshi, second one is for his wife, third and fourth one is for his daughters. And V7, VA12 is just for helping the experimental biologists to know what are the adjacent regions in the genome, so that they can do experimental validation. And the second but last column is telling the chromosome number where it was found. So I used RSQLite. If you can go to the next slide. So this was all extracted using the model, using knowledge of Poisson distribution and the model that was built, and then all the not important variables such as V4, V5, V12, I put it as null, as you see on the right hand side of this. And on the right bottom side you see a head SNP A I've mentioned, where is what is the crux of all this big data parallel analysis that's done on the cloud. It can be a private cloud such as the cluster. And on the left hand side it's the SQLite statements I've tried to convert into. So here is after this thing I've also introduced some more data cleaning steps, such as there were certain SNPs, single nucleotide polymorphisms, which matched to a non-chromosomal region. I mean, it matched to the chromosomal region, but where exactly it belonged to, it was not known. So those were also removed. And so, say for example, if SNP A is of Mr. Joshi, after cleaning those data, I got it reduced from by a couple of thousand values. And this was also done for his wife and for his 2 daughters. Can we go to the next slide, sir?
Yeah, I already pressed it. It takes some time.
Yeah, yes, sir. So this is what has been done finally. So the big data, which was about half a terabyte in my case, about 49,000 or 500 gigabytes. I'm getting a data which is or only about 260 megabytes of the sum of the SNPs, the set of the SNPs that I wanted, using the model and the Poisson distribution knowledge, done on a standard cluster such as the one shown in the picture. Yeah. So now let's look at the qualitative analysis. So here is just a summation of the A10, A5. The first one stands for Mr. Joshi, B is Mrs. Joshi, C and D are the two daughters. We see that the single nucleotide polymorphism data is much less than the other variations, which is what we would have expected. So qualitatively we know that what we have done is correct. If we do go to the next slide. So that was done for the whole genome, and I wanted to ensure that even at the chromosomal level that is also being observed. So for chromosome number 20, I looked at the total variations and found and the variations just due to single nucleotide polymorphism, which is on pink, shown in pink, and it also exhibited the same pattern, and which further gave us confidence that what we did is using our model was good in a qualitative picture. If we go to the next slide, we see gender determination. So we know that Mr. Joshi is a male, his wife and two daughters are female. So if I pick up the Y chromosome and look at the variations in the single nucleotide polymorphism, then the women should exhibit lesser SNPs than found in the male, and that is also shown in this qualitative picture. And if I go to the structural variations, the difference in what is found in the male and the three females is even more pronounced, and that is because I won't get into the biology of it, but qualitatively we have done a good analysis. And then if I go to the quantitative analysis, what I want to see is how much of the SNPs from mother and father was inherited by the two children. So I did using a SQL command. I did a union of mother and father SNPs, and here's a head to look at the first few data, and so see the total amount. So we get a sample, or rather a population where I have the whole SNP from mother as well as father combined into one. So I then look at. Can we go to the next slide, sir? So I have the set of SNPs accumulated from mother and father, and I want to compare for child C, which is Razia, and the second child, which is Kavita, and then I look at the intersect of the SNP found in C and the SNP which is found in the union of A and B, and that comes out to be a big number. And so from there we can, if we go to the bottom of the slide, we can see that it is about 20% which is not being inherited. The rest 80% of the SNPs are inherited from mother and father. And if we go to the next slide, this even for child C, the other child Kavita or Razia has a name B, we again do the same kind of computation and find out that about 21% of the SNPs are not inherited. 80% is roughly inherited. So what we can say is that that we have 80% confidence that the SNPs that we have detected using our model and Poisson distribution knowledge are those which have been for which we have more confidence, and thus the SNPs, if we relate it to the disease and thus the business behind it, can have 80% chances of success. And yeah, so any more this extra work slide, it doesn't make sense. I mean, I just wrote it for yeah. So I mean, the further step that I want to do is probably do a genome-wide association studies. I don't know whether I will be able to do it for four individuals, but what is done essentially in genome-wide association studies is that it's not just the SNP, but the combination of SNP that are related to a disease, and we try to do some statistical techniques to find out how well they are related. That is my vision to do it further, but yeah, any more inputs will be really appreciated.
Yeah, I'll have a separate session again with you. I'll talk to you later. And of course, I mean, it's a very well done thing. and well done. But let me know one thing. I mean, you did a lot of things when you started this course. After interacting, we knew that a lot of things are already known to you. But still, why did you join this course? I mean, why did you feel that to join this kind of course? I mean, did we really add some value to your career? I mean, any fundamental knowledge anywhere actually? Maybe you are from totally biased that kind of thing. Anything in the finance equipment. How do you feel that? How do you rate the whole course actually, which got imparted? I mean, I'm very serious about it. I'm curious and serious also. Do you feel that Gautam, Sakha, we all could add any value to your knowledge base? Anything?
If it is due to the project I mean, I could have chosen a project which was more business oriented, but I chose this project because I am already into life science research, so I thought maybe I should try to fit in the things that I learned from this course somewhere in terms of knowledge and explanation and what things that I do.
No, I'm not asking.
But of course,
why did you choose this? Why did you choose this project? I'm telling. With this kind of knowledge base, and did you feel that we people, myself, Tathagata, Sham Karmakar, we could add some value to your knowledge base? Did you learn anything additional what you what you knew earlier?
Yes, of course. I mean, this course has been very, very useful because I think no matter even if you're working as a technical person, it's good to have business overview, and knowing the statistical techniques that you learned is definitely applied to business, but those techniques are also largely applied in technical domains. So I mean, I did learn a lot in the course in terms of modeling and different kinds of statistical techniques that are being used. I mean, if I get make a career purely into business, then this will be purely translated. But as of now, I'm into mid of technical, so I mean, it is definitely helping me in yes. I mean, Tathagat sir and all the other faculties I think are very great. I mean, they are a very knowledgeable person. So I'm not from this kind of statistical background, so there was definitely a lot of knowledge that I gained in.
Okay, thank you very much for that, because I was wondering. So you can say, so you used to carry out or execute this kind of things earlier also, but where you were lagging is that business part of it. I mean that bringing finance, economics, supply chain into. So tomorrow, if you get into true sense business analytics, which is not very much specific to biostat and all, probably we could add some value to you. I was wondering that where actually we could add value to a person like Dr. Abhishek Singh.
I mean, there was definitely a lot of things that I learned in this course. I mean, if I just worked on business domain, it will be very useful. But even if I continue in the domain I've been working so far, even there a lot of the techniques can be applied.
Okay, thank you very much. We'll talk later again. Okay.
Thank you, sir. Yes, sir. Thank you.
Well done, boss.
Thank you.
Okay, there are a lot of people which are pending. I don't want to be rushed through. So probably I'll take Tanmoy and lot of. Please take Samrat next. So people who are yet to be taken, don't worry. I'll fix another day. I don't mind going for another 2 hours extra session to do justice to all of you. You put a lot of effort, and I want to hear it properly. Though it was a 15 minutes time, I took more than 15 minutes because I liked it. I'm enjoying it also.
Hello?
Yeah, Samrat. Samrat, sorry, you have got very little time left, but still quickly go through. If you cannot finish today, probably not, then we will have another day. Because few more groups are there, they could not send the whole stuff. I don't want to do injustice to them. We'll listen to them later on. Probably in one of the days, let me see if we can have a session 1 hour early than 2 o'clock. If the studio is available, I'll let you know, and then we'll have the session, okay? But go ahead, yeah, now. Which is the one actually in your case?
Actually, we didn't know that we have to submit the presentation, so we have made it right now. So we have mailed it to you, sir.
Yeah. Which one?
Sir, all-state purchase petition plan. All-state purchase petition plan.
All-state purchase petition plan. Where it is? It is not here?
Sir, I have mailed you just the 5-10 minutes back.
Mail now. Okay, then I have to open it. But then they will leave it today. Because then I have to go to my mail. We'll have next day.
Okay.
There's very little time is left.
No problem. Actually, this is fine for us also. We'll get time to prepare more. So we'll get time to prepare more. Actually, we are not that obvious as the other person.
Okay, let me take Avinash Kumar and all. Let me see. Deepak Tiwari. Let me take Deepak Tiwari. Yes, Deepak. Deepak, actually, I don't think we are only left with 10 minutes. 10 minutes is sufficient enough for you to do justice. You just give the overview today. And we'll have, as I told you, maybe in one of the days we'll start the class 1 hour early, or we'll end after we'll plan accordingly and we'll finish it. And just give the overview and we'll talk later. Yeah. Which one is yours?
It will be better, sir. It will be better, sir, than we go into. It will be better if we go in for the next class, sir. Hello.
Deepak.
हेलो
या नाराज हो गया थोड़ा क्या? गुस्सा हो गया हमारे ऊपर?
नाराज क्यों?
गुड इवनिंग। तुम्हारा है क्या? देखो तो यहाँ कहीं है क्या प्रेडिक्शन इनकम हाउस होल्ड? इसमें है कहीं?
सर प्रोजेक्ट इन बिग डेटा, प्रोजेक्ट सीट, इनकम सीट,
प्रोजेक्ट
पहला वाला स्लाइड, द अर्लियर स्लाइड सर।
अर्लियर इसका पहले वाला?
हाँ, द प्रोजेक्ट इन बिग डेटा एनालिसिस, उसके पहले, उसके ऊपर।
प्रोजेक्ट इन बिग डेटा का ऊपर वाला, ये वाला?
हाँ।
फिर एक काम करो, should you open the Excel sheet?
Yes.
Okay. So give the overview. I don't think we are only left with 5 to 8 minutes. You don't have to go through, but if you give me what you tried to do and all, so that next day you can start from there. Hello. I'm not able to hear you. Not able to hear you. Your voice is not. The volume. Oh, you see that your microphone. I think, but she was speaking earlier. No, we could hear him. Now we cannot hear it. The technical guy is trying to do something. Hello. Yeah, Deepak. दीपक, नो आई एम नॉट एबल टू हियर. दीपक छोड़ दे यार, अभी ऐसे भी 7 कितना हो गया, 7:53. सॉरी, ओ नॉट एबल टू हियर यू. 5 मिनट में यार क्या होगा. So let us end it over here today. We'll have a session tomorrow again. I mean, we'll decide when to have it. We'll plan another day for the rest of the people who are left. Not only the people like you who could not present today, but also some of the people they could not submit on time and all. So let us have them also on that day. So we'll plan accordingly and let you know. Maybe we'll in any of the recap session we'll squeeze 1 hour, or we'll request you people to come 1 hour on hour early. We'll have it happen. Okay.
Okay.
Okay. Chalo.